All right, let's take a look at this problem here. To figure out, I have to start with actually tension 3 for this problem, because that one's the most straightforward. If we look at this object, it's going to have a force of gravity downwards, Fg, and a tension 3 pointing upwards. These have to be equal because the cement bag is not accelerating. And so we know that the upwards tension force has to be 500 newtons here because it tells us that the weight of the object is 500 newtons. We go ahead and take a look. We see that we got that one right. Now, the other two, basically what we're going to do right now is take a look at this point right in between the objects, basically this knot right here. And in this knot, it's got 3 tension forces coming off it, T1, T2, and T3. The important thing to take a look at here is that these 3 forces have to sum up to 0. If they don't, then there would be an unbalanced force on this knot. And since we're assuming that the strings or the wires are basically massless, it's not possible for there to be an unbalanced force on anything that's in there. Then it would be accelerating and with actually an infinite acceleration. So here's what we have to do. We have to take a look at the x and y components and say that they all add up to 0. So what we can start off with is looking at the sum of the forces in the x components and in the y directions. So if we look at the x and y components, the only two that have x components are going to be t1 sub x and t2 sub x. And we add these together, we get that they equal 0. And so they're in opposite directions, so one would be positive and one would be negative. But the really important thing here is that because when we add these together, well, I guess you can really say that since one of them is in the opposite direction, you could say that it's that this would be t1x minus t2x is equal to 0. And so this tells us that the x components of these are actually equal to each other because they balance out at the end. This is an important relationship that we'll use later on in the problem. So this is an equation we're just going to hold on to. We'll bring it back later. The other thing that's important here is that t1y plus t2y are both pointing upwards and t3 is pointing downwards. And that's got to also be equal to 0. So once we take a look at both of these equations together, we can actually now just go ahead and rewrite all of our t1 y's and x's in terms of their sines and cosines throughout. So typically sine is our horizontal, or is our vertical, and cosine is our horizontal. But in this case, since these angles are measured up here, actually no, it's still the same for this one because these angles are measured with respect to the horizontal. So the sort of as we break these up into their components, we've got the y is going to be the one that is opposite of this, so that's going to be our sine component. So the y ones are going to be sine theta, so we can go ahead and rewrite this as t1 sine theta 1 plus t2 sine theta 2 minus t3 equals 0, or you can write it equals t3, however you want to do this, but overall we'll probably wind up solving for one of these. And then in this equation up here we get that t1 cos theta 1 is equal to t2 cos theta 2. And so these are sort of the two equations that we're going to be looking at. Let me rewrite these so we can take a closer look. All right, so here we have them both. We can go ahead and, there's a number of different ways that we can go through to solve what these different values are. I'm probably just going to solve this top equation for t2. So what I'm going to do is just divide both sides by cosine theta 2. All right, and then we're going to plug that in for t2 here and keep going. Here we go, plug this in. I did replace sine theta 2 over cos theta 2 with tangent theta 2. And so we can go ahead and now start plugging everything in, solve for t1, and then plug everything in. All right, so we've got this right here. Sine theta 1 plus cos theta 1 times sine theta 2 is our factor right there. So I'm going to pull up a calculator. All right, and we've got, it's going to be sine of theta 1, which in this case was right there, 61 degrees, plus the cosine of 61 degrees times the tangent of 37 degrees. That's this number there, and then we're going to do our 500 newtons, the weight, or what T3 was divided by that number to get ourselves an answer for what is T1. So we get tension 1 is equal to 403.24 newtons. And we can check our answer there, 403 newtons. Wonderful. And then the last thing that we need to do is take any of our other equations, which actually I will use this equation right here, and just go ahead and solve for T2. Since this is our value for T1, all that we need to do is multiply by the cosine of 61 over the cosine of 37. And in this case, we get 244.78 newtons. And there we go, 245 newtons. That gives us this problem. Good luck with that. If you're still having trouble, let me know. I can take a look at your work, and we can make sure you get that one done.